Introduction. When you're building and maintaining ASP.NET Web Forms applications backed by SQL Server, knowing how to monitor system health and diagnose performance issues separates the developers who just write code from those who truly own their applications in production. This audiobook covers the monitoring and performance concepts you'll need, both for interviews and for the day-to-day reality of keeping enterprise applications running smoothly. Chapter 1. The Performance Mindset. Before diving into tools, let's establish the right mindset. Performance isn't something you bolt on at the end. It's a consideration throughout development. When you're writing that T-SQL query, think about execution plans. When you're building that web forms page, think about view state size and postback frequency. When you're integrating with third-party platforms, think about timeout handling and retry logic. The three resources you're always balancing are CPU, memory, and I/O. CPU bottlenecks show up as slow processing and queued requests. Memory pressure causes garbage collection storms and eventually out-of-memory exceptions. I/O bottlenecks, whether disk or network, manifest as waiting, timeouts, and throughput limits. Most performance problems ultimately trace back to one of these three. For web forms applications specifically, you're also managing the abstraction overhead. View state serialization, control tree construction, the page lifecycle, these all have costs. Understanding where time goes helps you optimize where it matters. Chapter 2. Windows Performance Monitor. Performance Monitor, or perfmon, is the foundational Windows monitoring tool. It exposes hundreds of performance counters organized by category. Learning to read these counters is essential for diagnosing production issues. For overall system health, start with the processor category. The percent processor time counter shows CPU utilization. Sustained values above 80% indicate CPU pressure. The processor queue length counter shows threads waiting for CPU time. Values consistently above 2 per processor suggest CPU bottleneck. Memory counters tell you about RAM usage. Available MB shows free physical memory. When this drops below a few hundred megabytes, the system starts paging to disk, which devastates performance. Pages per second indicates paging activity. Occasional spikes are normal, but sustained high values mean memory pressure. The .NET CLR memory category shows managed heap statistics, including garbage collection frequency and heap sizes. Disk counters reveal I/O performance. AVG disk queue length shows pending I/O operations. Values above 2 per spindle suggest disk bottleneck. Percent disk time shows how busy the disk is. For SSDs, these thresholds are more forgiving, but the counters remain useful for relative comparison. Network counters track bandwidth and connection states. Bytes total per second shows throughput. Current connections in the TCP category helps identify connection leaks or exhaustion. For ASP.NET specifically, the ASP.NET and ASP.NET Applications counter categories are gold. Requests current shows active requests. Spikes here indicate slow request processing. Request wait time shows how long requests wait before processing begins. Requests queued indicates backlog. Request execution time shows processing duration. These counters directly reflect your application's responsiveness. The worker process restarts counter catches application pool recycles. Frequent restarts suggest crashes or memory limits being hit. Pipeline instance count shows concurrent pipeline instances. You can view counters in real time or log them to files for later analysis. Creating a data collector set that captures relevant counters lets you establish baselines and compare during incidents. Chapter 3. Event Viewer and Logging. Event Viewer is where Windows and applications record significant events. The Windows Logs section contains system events for OS-level issues like driver failures and service crashes, and application events for software problems including .NET exceptions. The Applications and Services Logs section has more detailed logs including Microsoft.NET Runtime events and IIS-specific logs. When an ASP.NET application throws an unhandled exception, it typically appears in the application log with source ASP.NET and the full exception details. IIS logs its own events here too: application pool starts and stops, worker process failures, configuration issues, and binding conflicts. Learning to filter and search Event Viewer efficiently saves significant time during incident response. Custom views can filter by source, level, and time range to focus on relevant events. For your own applications, structured logging is essential. Whether you use Log4net, Nlog, Serolog, or the built-in system. Diagnostics tracing, consistent logging practices make debugging possible. Log meaningful events, request starts and completions with timing, database calls with duration and parameters, external service calls with outcomes, third-party integration responses, and, of course, exceptions with full-stack traces and context. Log levels matter. Debug and verbose logging helps during development, but overwhelms in production. Info level captures significant business events. Warning level flags concerning but non-critical issues like retried operations or approaching thresholds. Error level records failures that need attention. Configure appropriate levels per environment, and consider making log levels adjustable without redeployment for production troubleshooting. Centralized logging becomes important as systems grow. Aggregating logs from web servers, database servers, and other components into a single searchable repository, whether that's the Elk Stack, Splunk, Azure Monitor, or even a simple database table, enables correlation across systems when diagnosing issues that span multiple components. Chapter 4. SQL Server Monitoring. Since you're working extensively with SQL Server and T-SQL, understanding database performance monitoring is crucial. SQL Server has its own rich set of monitoring capabilities. Activity Monitor in SQL Server Management Studio gives a real-time dashboard. It shows processor utilization, waiting tasks, database I/O, and recent expensive queries. This is often your first stop when the database feels slow. Dynamic Management Views, or DMVs, expose detailed internals. The sys, DM exec requests view shows currently executing requests with their wait types and resource usage. The sys. DMX query stats view provides cumulative statistics about query execution, total elapsed time, CPU time, reads, writes. Sorting by these metrics identifies your most expensive queries. Wait, statistics reveal what SQL Server spends time waiting for. The sys. DMA's wait stats view shows cumulative wait times by wait type. Pagiolatch waits suggest disk I/O bottlenecks. CX packet waits indicate parallelism overhead. LCK waits mean locking contention. Understanding wait types helps target optimization efforts. Query execution plans show how SQL Server processes your T-SQL. Look for table scans on large tables. These often indicate missing indexes. Nested loop joins on large datasets can be problematic. Key lookups following index seeks suggest covering indexes might help. The estimated versus actual row counts reveal cardinality estimation issues. SQL Server Profiler and extended events capture detailed query activity. You can trace specific queries, filter by duration or database, and identify exactly what's executing. Extended events is the modern replacement for Profiler with lower overhead. Index maintenance matters for sustained performance. Fragmented indexes slow queries and waste I/O. Monitor fragmentation levels with sys. DMDB index physical stats and rebuild or reorganize indexes on appropriate schedules. Chapter 5. IIS and ASP.NET Diagnostics. IIS provides several diagnostic capabilities for web applications. Failed request tracing, also called FREB, captures detailed information about requests that fail or take too long. You configure rules specifying which requests to trace by URL pattern, status code, or time taken, and IIS generates XML logs with complete request lifecycle details, including module execution times. IIS logs record every request with timestamps, URLs, status codes, bytes sent, and time taken. Analyzing these logs reveals traffic patterns, error rates, and slow endpoints. Log parsing tools or importing into databases enables sophisticated analysis. Worker process management affects both reliability and performance. Application pool settings control recycling behavior, time-based, request-based, memory-based. Recycling clears accumulated state and potential memory leaks, but disrupts in-process session state and causes cold start delays. Balance recycling frequency against these costs. The ASP.NET Health Monitoring feature provides built-in event logging for application lifetime events, errors, and performance thresholds. Configuration in web.config specifies which events to capture and where to log them. For deep .NET diagnostics, debugging tools like WinDBG with the SOS extension can analyze memory dumps. When applications hang or crash mysteriously, capturing a dump and analyzing managed heaps, thread stacks, and locks often reveals the cause. This is advanced territory, but knowing it exists and when to reach for it distinguishes senior developers. Chapter 6: Application-Level Performance. Beyond infrastructure monitoring, application code itself needs performance attention. Profiling tools like Visual Studio's Performance Profiler, .trace, or Ant's Performance Profiler identify hot paths in your code. They show where CPU time goes, which methods are called most frequently, and where memory allocations happen. Memory profilers specifically help identify leaks, objects that accumulate over time because references prevent garbage collection. For web forms specifically, watch view state size. Large view state increases bandwidth, slows page loads, and adds serialization overhead on both server and client. Disable view state on controls that don't need it using enable view state equals false. Consider server-side state storage for very large pages. Use browser developer tools to inspect the low view state hidden field size. If it's larger than your visible content, you have a problem. Database access patterns often dominate performance in data-driven applications. The N+1 query problem, loading a list, then querying for each item's details separately, is common and devastating. If you display 100 items and each triggers a detail query, you've made 101 database round trips when 1 or 2 would suffice. Batch operations, eager loading with joins, and query optimization make dramatic differences. Parameterized queries enable execution plan reuse. Dynamic SQL forces recompilation. Connection management matters. Connection pooling is enabled by default in ADO.NET, but connection leaks, failing to dispose connections properly, exhaust the pool and cause timeout failures. Always use using statements or explicit dispose calls. The min pool size and max pool size connection string parameters tune pool behavior. Caching reduces redundant work at multiple levels. Output caching stores rendered page content, serving identical responses without executing page code. Data caching stores query results or computed values in memory for reuse. The ASP.NET Cache object supports expiration policies and dependencies. Distributed caching with Redis or similar enables sharing cached data across web servers in a farm. Cache judiciously. Stale data causes its own problems, and cache invalidation remains one of computing's hard problems. Asynchronous operations improve throughput for I/O-bound work. Async database calls, async HTTP requests to third-party services. These release threads back to the thread pool while waiting for I/O completion, enabling more concurrent requests with the same resources. In web forms, async pages require the async equals true page directive and use of register async task or the newer async/await patterns. Chapter 7: Interview Preparation. For interviews, be ready to discuss your approach to performance troubleshooting. A good answer walks through the diagnostic process methodically. Reproduce or observe the issue, gather metrics from perfmon and logs, identify the bottleneck category, CPU, memory, I/O, or external dependency, then drill into specifics with appropriate tools. Demonstrating a systematic approach impresses more than reciting tool names. Know the key performance counters for ASP.NET applications and SQL Server. Be able to explain what they measure and what values indicate problems. Requests current and request execution time for ASP.NET, processor percent, and available MB for Windows. Batch requests per second and buffer cache hit ratio for SQL Server. Discuss specific optimization techniques, indexing strategies for common query patterns, Query optimization approaches like avoiding select star and using appropriate joins, caching approaches at different layers, view state management techniques. Concrete examples from your experience are compelling. If you optimized a slow report from 30 seconds to 2 seconds by adding a covering index, that's a story worth telling. Understand the trade-offs. Caching improves speed, but risks stale data. Async improves throughput, but adds complexity and debugging difficulty. Indexing speeds reads, but slows, writes, and consumes storage. Demonstrating awareness of trade-offs shows engineering maturity rather than just pattern application. When asked about monitoring in production, discuss logging strategies, alerting thresholds, and baseline establishment. Production monitoring isn't just reactive troubleshooting, it's proactive health tracking that catches degradation before users complain. If asked about Jenkins or CI/CD integration, connect performance to the pipeline. Performance tests can run as part of builds, catching regressions before deployment. Load tests validate that changes don't degrade throughput. Monitoring dashboards can track metrics across releases, correlating deployments with performance changes. Conclusion: performance monitoring and optimization is where development meets operations. For a web forms developer working with SQL Server, understanding these tools and techniques enables you to build applications that perform well, diagnose issues quickly when they arise, and speak credibly about system health in technical discussions. This knowledge demonstrates that you don't just write code, you own applications end to end, from development through production operations. End of audiobook.